Oh, it doesn't have my writing on it anymore. Weird. Okay. I don't think I have it written down either. I think it's 8 pi out front. I can't remember. So you would multiply that by that 1.3 decimal, and I'm not sure where that will get us in terms of, I think it gets us close to what we want, which is 32 point something from the calculator. And I'll double check on that as well. So hopefully we're on the right track here. I just want to give you something to look at over the weekend. Hopefully I haven't made some kind of glaring error. I don't want to steer you in the wrong direction and have you spending all sorts of time on this. That's not necessary. So, oh, I see, it's replaying. It's replaying what I did. Okay, I'm going to stop here and send you this. Okay. So going into the next step, and we know where all this is coming from. One of the things that I think we didn't talk about yesterday was that when you're putting in the arc length formula, it can be 1 plus dy dx squared, all square rooted, or it can be the square root of 1 plus dx dy squared, and they're interchangeable. And so the way that they have this set up, what they're doing differently is that they're using the parameters on the y-axis. They're going from 0 to b on the y-axis, and we were using the radius 0 to a on the x-axis. And I don't think that's going to matter if we set this up like that for the ellipse. So if we follow what they're doing here, it's the same formula as what we were doing before. What we're going to end up with here, instead of looking at this, because b is 1, this guy would now look like this, right? It would be 4 pi times the integral over 0 to, would it be 2 or 1? That's 0. It would be 1, right? Because of the b value is 1. Square root of, and then a squared y is just going to be, oh sorry, that's not a squared, that's a to the 4th y. So that's going to be 16 y squared plus b to the 4th. B is just 1, so we'll leave that out. And then a squared is 4 minus 4y squared, and then that's going to be over 1 dy, right? And so the rest of this is just simplifying. And so if we work with that from our equation that I have written over here, then I think we might end up with a bit of a simplification. Let's see what happens anyway. We've got 16y squared. That's going to give us a minus 4y squared, and then a plus 4 dy. So a 4 can come out of that whole thing as a square root, and we would be left with 4y squared minus 1y squared plus 1 dy. 3y squared plus 1 dy. So I'm not sure if that helps us a whole lot. It's sort of similar to what we got before, but I think by setting it up this way with the b equal to 1, it gets rid of all those fractions that we were dealing with before, because we had everything over 4 because we were dealing with, we were setting it up with the radius on the x-axis. So if we have that, and I'm just thinking of what would be next. I'm thinking it's a u substitution, but then the du would be 6y. And we don't have the y here. So we've got to figure that part out next. Let me work on that, but I just wanted to kind of give you that so that you can see that we may not have to go into all of those crazy epsilon things at the bottom in order to make this work. If we wanted to check on this, what we could do is maybe go into Symbol Lab, maybe that's what I'll do next, and see what the integral of this guy is. The 2 can come out, right? So let me just move this whole thing up a little bit here. The 8 pi, and then we would just have root 3y squared plus 1 dy. So maybe that's what I'll do next, is go into Symbol Lab and see what it tells me in terms of the integral, so that we know we can integrate that. And if we can, then I think we're like 80% there in terms of it being able to find the surface area of this guy, which might make it a little bit easier. So I'll get back to you on that. Okay, I went over to Symbol Lab and tried it. If I did this correctly, and I'm going to have to check on that and do some double checking with all of this, it actually did compute the integral for us, and so I put all the steps here that it showed me. Now it's giving the answer as a decimal. Sorry, I'm just kind of interpreting this right now because I'm trying to do this before I leave. It's giving me a decimal answer here. And then don't forget that we have, is it an 8 pi? I can't remember. In front that we need to multiply by this as well. And then at the end, you're going to have to double your surface area, because all we're finding is the positive positive surface area above the x-axis, right? So we have to double it, which is exactly the same. Remember we were talking about that with the volume question, and we were saying, why is it half? And it's because we were just finding the positive side. We were just finding the top half, and so for the bottom half you would do the exact same thing, which would double the volume of the entire shape. So in this case we would have the 1.38 times, I think it was like 8 pi on the previous screen. Let me see if I can go back there.